Hi folks, Modelling Mark here again. In this video we're going to be looking at the wheelhead collar, which is this bit here in blue. A little bit difficult to see because it's hidden behind the wheelhead bracket. Basically it's the collar that goes over the vertical column and the wheelhead bracket is mounted to it. Here's the plan view, and it's this bit here, and the wheelhead bracket is mounted on it and held with the two grub screws. First operations are to put this in a 4-jaw chuck, bore it and face it. That's quite straightforward. Next operation, to get this faced off true, I need a mandrel. So this is my very rough sketch for the mandrel. This is an expanding mandrel. The design is actually Joe Pye's design. I'll leave a link to his video in the description. If you're watching Joe, thank you, this is really useful. It's a 19 to 20mm spigot to go in my ER32 collet. Then the 1.5 inch diameter, which is true to this 1.25 inch diameter. So I can index off here so I can find the centre of the bore. Then we've got a relief cut. Then there's 6 petals, just saw cuts, which can expand out. And there's an M8 countersunk screw goes down there, which will force the petals out. So here's the mandrel in reality. The sort of 19 to 20mm spigot. This is not turned to its final dimension yet. That'll be done when it's mounted in the collet to make sure it's true. There's the relief cut and the 6 petals with the countersunk M8 thread, and that thread goes down just below this relief so we get a nice strong bite from the thread. The first job, put the 4-jaw chuck in the lathe and get this centred up. That's the casting mounted in the 4-jaw chuck, and I've got it running as true as I can get it. That face and that face are nearly square, and it's pretty much centred, probably to within 20 or 30 thou. Anyway, it's about as good as I can get it. Hopefully it'll be good enough. I'll start by boring out the bore. This is going to be a long drawn out process, so I'll switch the camera off now and I'll bring you back when I'm nearly done. We should be nearly there now. Oh, 2 thou to go. I'll try the bar in place. Oh, that is so close. That's a nice good fit, no wobble there. Now we come to facing off this end. Now if my measurements are right, I need to take about 80 thou off here. But as soon as I clean it up, I'll, as best I can, measure from the centre of the casting to the edge, which wants to be about 1 3/8. That's cleaned up fairly nicely now. And we've got about 145 thou from the centre of the casting, which gives me about another 55-60 to come off. Looks like it's got about 30 thou to come off. It's a casting, so it's impossible to be precise. Should have done this before. 1, 2, 3 block. Now I can go from the edge to what looks like the centre of the boss, which gives me another 20 thou to go. That's come out a very nice finish, and it looks like it's about the right distance. I mean, if it's too far out, then I can always stick it back in the mandrel and take us a bit more off. But fingers crossed we're about right. I've put the mandrel in now. That's in the 19mm collet chuck. And now I'm just going to put the screw in the end and just tighten it just a smidge, hopefully to take some of the spring out of these petals. It should also spread the petals just a fraction, so that when I take the screw out, they'll shrink back in and make it easier to get the collar onto the mandrel. Right, there's quite a lot of stick out there, so fine cuts is the order of the day. As I mentioned before, this has been taken down almost a size. I've just got 40 thou to come off the diameter. That'll truing it up and making sure it's a nice good fit. Okay, that's a nice fit. And that doesn't take much at all to lock it up solid. Right, now I've got to face this down until I get an overall length of 2 3/4. There's about 70 thou to come off that. That's actually chattering a little bit, probably because of the lot of stick out. Just the last 6 thou to go. Okay, that's come out about 1 thou under, which I can live with. Of course, what I did forget to do is when I cleaned up that surface, I forgot to clean up this surface. And that's important because that surface of the arbor and that surface need to be perfectly concentric. Fortunately, I can take this off, skim up that face and put this back on without losing concentricity. That's fixed that minor cock up. So the last thing to do on the lathe is to take these 2 bushes down to a 1-inch radius. Again, slow speed because it's an interrupted cut going through a skin. About 46 thou to go. That looks about right. Now, of course I can do that one. That doesn't need measuring because I can come down to the same number on the dial. That's that one finished, both the same diameter. Now we can go over to the mill. In the mill now, we've got the collar set in the collet chuck in a square collet block. We've got a machinist jack under here just to give a bit extra support because there's an awful lot of overhang. I've zeroed the DRO over the centre of the collar, so that's zeroed on the y-axis and on the x-axis. I'll put the pointer in the edge finder and line the casting up so that this spigot, is that the right word? I don't know, sticky up bit anyway. So this is in line with the centre of the milling axis. That seemed to be the best way of sorting out this casting. Milling cutter's in the mill now. This is all set up. DRO's set to 0, 0 over the centre. I've got a metric milling cutter in here. I'm working in metric for a change, and I need to clean this face off 14.52 millimeters from the centre this way and from this way. I've actually come across 14.55. I'm going to nibble down and then I shall just come back a smidge and do one cleaning cut off the face. Just take it over just that tiny smidge more to 14.52, and I can take a final cleaning up cut across that face. That face is done. That's come up very nicely. Almost a mirror finish there. I'll do the other side off camera because it's exactly the same. While I've got it in this orientation, I'm just going to clean up the edges of these lands. The casting is a little bit mismatched and they're not the same size. So I'm just going to do this one by eye because this looks the smaller of the two, and then I shall come over and do the other side just using the same measurements from the DRO. I've switched back to Imperial because I prefer Imperial, and that is exactly 1.00 inches. And that edge is cleaned up at 0.39 inches. Yeah, so that side is also cleaned up to 0.39 inches, and you can see that looks much nicer. And I'll just need to clean up the rest of it with the file and I'll clean up the rest of the casting. Now I shall go over and do the other side to exactly the same numbers, and it should be nice and even. I'll do that off camera because it's hidden behind the casting so you can't see it anyway. That's all machining in this setup. So now turn it through 90 degrees. And put the machinist jack back. Now I'm going to re-index it because I want to make sure that's absolutely accurate, and that needs to be reasonably accurate. I've re-indexed with the DRO so the bore is centered and we're central along here. Now this face just needs cleaning up. There's no specific measurement for this width. However, this boss needs cleaning up and taken to a height of 1 inch above the centre of the bore. So to get that, I need to touch off against here. And to find the centre of the bore, I need to measure this. And that's coming out at 1.495 inches. If I touch off against a 3/3 feeler gauge, I should end up with the end of the tool at 3/4 of an inch above the centre of the bore. That's just dragging slightly, so I'll call that 0. I've got 1/28 out to take off. That's cleaned up, but not by a huge amount. It's only just enough meat on the castings to get it to come clean. Right, now this one just gets taken down until it's cleaned up nicely. I will note the DRO measurement and take the other one down to the same amount, just so they're even. That's taken that face down to a DRO reading of 260. Right, now we need to drill a 60-degree centre in here, which is on the centre line height-wise and offset by 0.531 inch. The drawings call for a 7mm diameter centre, and I've got an 8mm centre drill. So I shall aim to go not quite all the way. That's actually measuring just about 7 mm. So I should be quite happy with that. Now this hole needs to be offset by 0.802. And this needs to be a 1/2 inch reamed hole. Oh, that drill did go all the way through. Touch and go. It was going deeper than the flutes. That was why I was taking lots of short pecks at it. That's the last drill, just left the final 64th to take out with the reamer. Alright, that's it for this setup. Now take it out, put it back in, and then I've just got this feature to do. I'll do that off camera because it's exactly the same as the other side. Here's finished casting, all bar the roughness, the uglies that need to be cleaned up with a file. I'll do that later. I think it came out very nicely. See, on this side the hole is nice and central in the bush. This side, unfortunately, it's a bit off. The casting halves weren't quite aligned, but that's completely invisible in the finished machine, so I'm not worried about that. Need a bit of a work with file around here and around here, but otherwise I'm very happy with that. Here's the casting in place on the vertical column. I've made the cotter pins, and on the drawing there's a distance piece on this side. However, I've just made the cotter pin a little bit longer, so I don't need a separate distance piece. It's just held in with an M8 bolt to the moment. The cotter pin is over length. I can shorten it down to adjust the angle that the ball handle sits when I do the final assembly. There we are, another piece off the list. Another 2 pieces really, because there's a distance piece done. That's it for this video. I hope you enjoyed it. An interesting part to make. Nothing too challenging, but a good methodical approach paid dividends. In the next video I'll be tackling the spindle in the spindle assembly, and that is going way outside my comfort zone. It's a fairly complicated and very precise piece made out of high tensile steel. and it tested me, but I got there in the end. Thanks for watching. If you enjoyed the video, please like and subscribe, and if you have any comments, leave them below. I read them all and I answer nearly all of them. Thank you. See you soon.